La primera cámara fue creada por Charles Louis Chevalier y Jacques Vincent en el año 1816.
La primera cámara digital registrada fue desarrollada por la empresa Kodak. Encargó la construcción de un prototipo al ingeniero Stephen J. Sasson en 1975.
Una cámara digital es una cámara que capta y almacena fotografías al instante. Esta se compone por un visor óptico, que es el visor que le permite encuadrar el sujeto de la imagen, un interruptor, que sirve para encender y apagar la cámara, y una palanca de zoom, que sirve para acercar o alejar el enfoque. Puerta de tarjeta USB, soporte para memoria. Permite el acceso para insertar o extraer la tarjeta de memoria. Soporte para muñequera. Permite fijar una muñequera. Botones de flecha y botón OK. Permite moverse entre menús e imágenes de la pantalla de imagen y reproducción, así como visualizar y todos los menús. Pantalla de imagen. Le permite encuadrar imágenes y videoclips con la opción vista en directo y revisarlos a continuación, con la opción reproducción, así como visualizar todos los menús. Botón Instant. Activa y desactiva el menú compartir de la pantalla de imagen. Botón de reproducción. Activa y desactiva la opción de reproducción de la pantalla de imagen. Botón vista en directo. Activa y desactiva la vista en directo de la pantalla de imagen.
With over 70 years of know-how and technological expertise, Canon continues to produce high-quality, user-friendly cameras. To ensure good photographs, it's vital to understand how light is captured and recorded. Like the human eye, a digital camera captures an object in the form of light through its lens. An image sensor, like the retina of the eye, then reads the light as an image. Finally, an image processor converts the image into a photograph. Digital cameras are made up of many parts. They must work in precise synchronization to produce good photographs. This feat is made possible by Canon's camera manufacturing expertise. To capture light without distortion, multiple lenses must be combined and precisely aligned. To design a lens, Canon conducts tens of thousands of simulations involving everything from the type of materials used to the order and arrangement of lens components. Next, 3D computer-aided design is used to design the entire lens. Lens production begins with the polishing of each piece of glass. Essential know-how regarding polishing methods, polishing times, and polishing abrasives can only be gained through many years of trial and error. Lenses are polished thousands of times and then washed. Following careful inspection, The lens surface is coated to reduce reflection and protect against scratching. The finished lens is so precise that if enlarged to the size of the Tokyo Dome Stadium, the margin of error would be less than the thickness of a business card. Canon's polishing tools are made by master craftsmen with decades of experience. It's here that traditional craftsmanship meets leading-edge technology. Canon innovation is the history of the camera lens. Canon mass-produced fluorite, an ideal lens material. Introduced aspherical lenses. Achieved the first practical application of an ultrasonic motor, and developed optical image stabilization technology. Canon's breakthroughs in lens technology have redefined photography time and time again. In the ongoing pursuit of the ideal lens, Canon illuminates photography for future generations. The image sensor converts light entering through the lens into electrical signals. Canon applies its original technologies and know-how to develop high-precision image sensors that offer high-speed processing and low power consumption. Each pixel stores tens of thousands of electrons. This has made possible a digital revolution in astrophotography. Canon produces its image sensors in a clean room environment in which even a single speck of dust is unacceptable, and the sensors do not come into contact with outside air. Using a method similar to semiconductor chip production, micrometer order circuits are etched onto large disc-like silicon wafers. Each sensor is cut from the wafer. After bonding and other processes, the sensor unit is complete. Canon's entirely automated production process ensures that each delicate image sensor meets the strictest standards of quality. Canon has nurtured its sensor technology since the beginning, and now it's flourishing. After the image sensor converts the image data into electrical signals, the image processor processes it. Canon's 70 years of camera-making experience led to the creation of the powerful Digic image processor. Digic narrows the gap between human color perception and a camera's objective measurement of color, producing colors beautiful to the human eye. Canon's research into seamless communication between cameras and printers is incorporated into Digic's circuitry. Today's digital cameras can recognize facial expressions such as smiles and winks, and identify over 30 faces at once. Canon digital SLR cameras support high-speed continuous shooting, and were first to make possible the shooting of full high-definition movies, thanks to their ability to instantly process large amounts of data. To create high-precision images, Digic performs countless processes, all in the instant you press the shutter. How are digital cameras designed and developed? First, a designer sketches the body of the camera. A 3D model is then created on a computer and the details are worked out. The color and texture of the different parts and the camera's overall ease of use are then considered. The data is then passed on to the development team. Designing on a computer, the team incorporates various features and functions, striving to achieve a body design free of waste. Canon employs 3D computer-aided design to speed up the process by reducing the need for trial production and prototypes. After repeated verifications, a digital camera is developed. But before being commercialized, it undergoes rigorous testing. It's dropped over and over, and its buttons are pressed tens of thousands of times until Canon believes it has a finished product. Now the camera's ready for production. Various camera parts which have been developed and produced at different locations are transported to this factory for assembly. Efficient production requires the delivery of a precise number of parts several times every working day. Each delivery arrives just in time for assembly. The production process is centrally managed, and progress can be confirmed from anywhere in the factory, a system that supports the smooth supply of parts. The final stage in the production process is assembly. Canon uses the cell production system to assemble cameras into finished products. In the cell production system, assembly workers are grouped in cells, which can respond flexibly to the production demands of various global specifications. Digital SLR cameras are carefully assembled by cells inside a clean room. The superior quality of Canon digital cameras is made possible by the company's advanced technologies and production systems. Conscious of protecting biological diversity, Canon sets stringent environmental standards. Through green procurement, Canon only uses parts with little environmental impact. The company recycles water at all of its factories. This is particularly significant during lens production, which requires large amounts of water. All water used for industrial purposes is purified at an on-site recycling facility and reused. Canon strives to reduce the resources it uses for packaging. The company has adopted a modal shift in its transportation methods in order to curb CO2 emissions. It's with such care and consideration that Canon products are shipped to customers around the world. Right now, somewhere in the world, a Canon digital camera is being delivered to a customer who will use it to capture precious moments. With leading-edge technologies and superior performance, Canon will continue to deliver the world's most trusted cameras.